Hi everybody, I wanted to go over this handout and fill in a few of the gaps that might be confusing you. So first of all, a rational function, remember, is one that looks like a fraction. So there's a polynomial on the top and a polynomial on the bottom. Inequality means you have a greater than or a less than sign. Okay, so here's a few general steps that you can go through. There are a lot of similarities between solving a polynomial inequality, so I will point some of those out as we go. First of all, this is true for both rationals and polynomials. We want 0 on one side. So you might have to do a little bit of algebra to make sure that 0 is on one side. Another thing in step 1 is that we would like a single rational expression on the other side. So if you have to subtract two fractions, then go ahead and use your addition subtraction rules to simplify that into a single fraction. Once you have a single fraction, step 2, you can factor the numerator and the denominator. If it were just a polynomial, obviously you would factor the whole side. But in this case, we're factoring the top and the bottom. Step 3, we're going to take each of those. So each factor in the top, each factor in the bottom, and we are going to set those individually equal to 0 and solve. That is going to give us all of the x-intercepts and vertical asymptotes if we would graph the left-hand side of our inequality. So then we are going to make a number line. We are going to mark our numbers on there. So we will have a certain number of intervals, and then in step 5 we're going to go ahead and check those intervals. So we're going to pick a representative from each interval. We are going to plug it into the function, and then we're going to mark if we have a positive answer or a negative answer. So because we have found all of the x-intercepts and all of the vertical asymptotes, those are the only places where the graph can change sign. So for each interval, we're either going to have a strictly positive sign or a strictly negative sign. So whatever sign we got for that representative for the interval is going to give us the sign for the whole interval. If there was a less than or greater than sign with no equal to sign, then you're going to use parentheses. But if there was an equal to sign, make sure that you only use brackets for the zeros of the numerator. I can talk about the reason why for that later. Okay, so here is example 1. So we have 12 over x plus 7 greater than or equal to 4. We see that it's a rational expression. We see that it's an inequality. We see that we do not have 0 on the right-hand side. So the first step that we will do is we will subtract 4 from both sides so that we can have 0 on the right-hand side. But remember that I also wanted this to be a single fraction. So in this case, I have a denominator of 1 here, a denominator of x plus 7. So that means I have to take this 4 over 1, multiply the top by x plus 7, multiply the bottom by x plus 7. That 4 gets distributed. So now I have 12 minus this. There's an implied set of parentheses around here, so you're going to end up with negative 4x and negative 28. So we subtracted the numerators, left the denominator alone. We now have a single fraction. Okay, so I have this inequality. Notice that I can pull a negative 4 out of the numerator. This expression will be easier to work with if I don't have that negative 4 in there. If I multiply both sides by negative 1/4, notice that the negative 4's are going to cancel on the left-hand side. And negative 1/4 times 0 is just 0. But remember that when you multiply by a negative, you have to flip the inequality symbol. So now we have x plus 4 over x plus 7 less than or equal to 0. If you set the numerator equal to 0, you get x equals negative 4. If you take x plus 7, set it equal to 0, the answer is x equals negative 7. When you put those on your number line, make sure you have them in the right order. So negative 7 is over here, and negative 4 is over here. So I want to pick a number over here, something between negative infinity and negative 7, a number here between negative 7 and negative 4, and a number here between negative 4 and infinity. We went ahead and chose negative 8 here, negative 5 here, and 0 here. If you take negative 8 plus 4 over negative 8 plus 7, Negative 8 plus 4 is negative. Negative 8 plus 7 is negative. Negative divided by negative is positive. And so I know that when I plug negative 8 in, I get a positive sign. If I plug negative 5 in, I get negative 5 plus 4, negative 5 plus 7, negative 5 plus 4, negative 5 plus 7. Negative 5 plus 4 is negative. Negative 5 plus 7 is positive. Negative divided by a positive is a negative. So that's why that negative is there. So then I'm going to take the 0, which is over here, plug that in. 0 plus 4 is positive. 0 plus 7 is positive. Positive divided by positive is positive. That gives me this plus sign here. So we noticed that we had a equal sign in our original inequality. We do want to worry about whether to use a bracket or a parenthesis at each of these endpoints. So if you plug negative 4 in to this, you get 0 on the top and something else on the bottom, but that's going to turn into 0. If you plug negative 7 into this, you get negative 3 on the top, but 0 on the bottom. You can't divide by 0, so the answer is undefined. So we can't say that the answer equals 0 at negative 7. We can say that the answer equals 0 at negative 4. So negative 7 is not a solution, and so there would be an open point or parenthesis at negative 7. When you plug negative 4 into the original inequality, you get a true statement. That means negative 4 is a solution, so that means you use a close point or a bracket at negative 4. We are looking at one of these two versions of the inequality. When we are looking at positive negative, we wanted to rewrite this with a 0 on the right hand side because we can't talk about positive and negative if we're not comparing our number to 0. Remember that greater than 0 is shorthand for positive and less than 0 is shorthand for negative. So for this one, we wanted to know when is it less than or equal to 0. That means when is it negative. We see that the function's going to be positive here, negative here, and positive here. This is going to be our solution set. That means that the numbers between negative 7 and negative 4 are going to cause the inequality to be true. We use a parenthesis at negative 7 and a bracket at negative 4. Here I have graphed the graph of y equals x plus 4 over x plus 7 in this Desmos graphing utility. And we have been looking at the inequality x plus 4 over x plus 7 less than or equal to 0. So the less than means that we want to know when this function is negative. The equal to means we're also interested in when this function actually equals 0. So graphically, if this thing is less than 0, that means the graph is below the x-axis. So we are trying to find the x values that cause the graph to be below the x-axis. And then the equal to means that this thing is allowed to touch the x-axis. That means that we are also looking for the x-intercepts for this graph. So we can see that the vertical asymptote is x equals negative 7. We can see that the x-intercept is at negative 4. So to the left of negative 7, the graph is above the x-axis. That means the graph is positive. Coming up, when we're really close to negative 7, coming all the way up to negative 4, the graph is negative. The graph is below the x-axis. And so that means that from negative 7 to negative 4, that means that the x values between negative 7 and negative 4 are the x values that cause this part of the graph to be below the x-axis. So the solution from that part of the graph are the x values between negative 7 and negative 4. Now there was an equal to sign in our inequality, but it doesn't make sense to say that negative 7 is a solution. It doesn't make sense to say that the graph equals 0 at negative 7 or that the graph is negative at negative 7 because the graph is not even defined at negative 7. So we have to use a parenthesis here at negative 7. We can say the graph equals 0 at negative 4. So you would use a bracket at -4. So we have parenthesis -7 to bracket -4. That's for that part of the graph. And then we look to see if there are any additional intervals that we are interested in. And we can see that from -4 to infinity, this graph is going to be positive. We know that that is the only x-intercept, so it cannot come back down and cross the x-axis anywhere. So this is the only interval that is of interest to us for that inequality.